All right, cool. So I'm James Watson. I'm a researcher here at the Stockholm Resilience Centre. And I've calculated how long it takes for things in the surface ocean to go from one place to another. I did this by going to particular places and dumping in tennis balls. I would then track where those tennis balls go as they move with ocean currents. Now the thing is, I didn't just go to these places and dump in a handful of tennis balls. I actually dumped in around 50 billion tennis balls. And the other important thing is I didn't do this in the real world. I did this for a simulated ocean that I ran on my computer. All right, so I'll show you a movie of these simulations. Here is the globe. The oceans are in dark grey, and in green are my tennis balls. And when I press play, you'll see how they get pushed around by ocean currents. First off, you can see some really nice oceanographic features. You can see how eddies capture these tennis balls and move them around. The second thing, as the movie goes on, you can see the broad patterns of connectivity. So you can see that all the tennis balls that were released off the US East Coast are drifting over towards Europe, following a really strong current called the Gulf Stream. If we let this play, we can see those broad patterns of connectivity more clearly. Now, the last thing that we get from this, and probably the most important thing, is an estimate of how long it takes, on average, for these tennis balls to go from any place in the global ocean to any other place. And what we found was that the average timescale is around 10 years, which actually is a really short time if you think about it. So this short timescale has lots of implications. It has implications for how phytoplankton, the algae of the oceans, will adapt to climate change. It also has implications for how pollutants are dispersed around the world's oceans. Pollutants like plastics, microplastics that are clogging up the world's oceans, they'll clog up different parts of the oceans more than others, depending upon where they get pushed around. Pollutants like radionuclides injected into the ocean when the Fukushima power plant disaster happened. So when those radionuclides were dumped into the waters off the east coast of Japan, it took about 3 to 4 years for them to move to the US West Coast. And we track that information too. So these kinds of simulations give us a lot of information about how the oceans are going to adapt to climate change and how other anthropogenic stresses like pollution are going to affect us now and in the future.